In this video, we will look at the union operation that can be performed on disjoint sets. We will also look at the union algorithm and how it works. There are many possible operations that can be performed on sets, but the subject of design and analysis of algorithms only considers disjoint set union and find operations which are very useful in several algorithms. Let us consider we have a disjoint set Si with the elements Ai, Bi, Ci, and so on till Zi, and another disjoint set Sj with the elements Aj, Bj, Cj, so on till Zj. Then the union operation on disjoint sets Si and Sj is a set of all the elements of set Si together with all the elements of set Sj. For example, let us consider the disjoint set S1 with the elements 1, 7, 8, and 9. The disjoint set S2 with the elements 2, 5, and 10. And the disjoint set S3 with the elements 3, 4, and 6. The union operation on disjoint set S1 and S2 is the set containing all the elements of the disjoint set S1, that is the elements 1, 7, 8, and 9, together with all the elements of set S2, that is the elements 2, 5, and 10. Now, since the sets S1 and S2 are disjoint sets, then after performing the disjoint set union operation, the sets S1 and S2 do not exist and they are replaced by set S1 union S2. Now let us look at how to perform disjoint set union operation on disjoint set S1 and disjoint set S2 represented as trees. The disjoint set union operation is performed on trees by simply making one of the tree as the subtree of the other. Therefore, one way is to make the tree representing disjoint set S2 as the subtree of the tree representing disjoint set S1, which is simply linking root of tree S2, that is node 5, to the root of tree S1, that is node 1, thereby making node 1 as the parent of node 5 and updating the parent in the array P at index 5 by replacing negative 1 as 1, since now node 1 is the parent of node 5. Now, since disjoint set union operation of set S1 and S2 itself is a set, so now the set S1 union S2 is represented by a tree which has node 1 as its root and all the other nodes as its children, which are the elements of the disjoint set S1 union S2. Now, this is one of the tree representation of union operation. The other way is that we can make the tree representing disjoint set S1 as the subtree of the tree representing disjoint set S2, which is simply linking root of tree S1, that is node 1, to the root of tree S2, that is node 5, thereby making node 5 as the parent of node 1 and updating the parent in array P at index 1 by replacing negative 1 as 5, since now node 5 is the parent of node 1. Even here, since disjoint set union operation of set S1 and S2 itself is a set, so the set S1 union S2 is represented by a tree which has node 5 as its root and all the other nodes as its children, which are the elements of the disjoint sets S1 union S2. Remember, once the union operation is performed on sets S1 and S2, the disjoint sets S1 and S2 don't exist individually. Instead, we have a new disjoint set S1 union S2. So this is how we can perform the disjoint set union operation on disjoint sets represented as trees. Now let us look at the union algorithm. We will call this algorithm as simple union, and this algorithm takes two parameters, that is I and j, which represents roots of the two disjoint trees. A simple solution for the union operation is to make the root of the tree of the first disjoint set I as the child of the root of the other disjoint set j. This is same as making root of the tree of disjoint set j as the parent of the root of the tree of the disjoint set I. So we will have the statement as P of I assigned J, that is, assign J as the parent of I. For example, let us perform the union of set S1 and S2. So we will call simple union algorithm passing the roots of the trees of the two disjoint sets S1 and S2. That is, in this case, we will call simple union and pass I as 1, which is the root of the tree of the disjoint set S1, and pass J as 5, which is the root of the tree of disjoint set S2. So here I is 1 and j is 5. And within the algorithm, we have the statement as P of I assigned j. That means j, which is 5, is assigned to P of I, that is P of 1, since I is 1. Therefore, since P of 1 is assigned 5, so in the array at index 1, we will have the value as 5. So the tree of disjoint set S1 with root as node 1 will become the child of the tree of disjoint set S2 with node 5 as the parent. So this is how union operation is performed on two disjoint sets using the simple union algorithm. Now let us discuss the time complexity of the simple union algorithm. The simple union algorithm is very straightforward. This algorithm contains only a simple primitive statement, which is an assignment statement, and takes a constant time. Therefore, the time complexity of simple union algorithm is O of 1.